Okay, welcome back to Artist Solves LeetCode, and we're on winter break now. I've already been doing a few of these, but we're gonna get right back into it. Um, Today we have a question called letter combinations of a phone number, and I just read the description before starting. This is exactly what it sounds like. You're given a string of numbers, and you want to return all possible letter combinations that number could represent. And we have them all here. I think it's standardized on all phones. I don't actually know, does anybody actually, use this still? Having the letter phone numbers? I feel like that was already phased out by the time I gained consciousness, but this, the LeetCode still exists. So, let's see how we can approach this. So, we're given the numbers. So let's say we have 2, 3, like how we have here. I think we can examine each number. Well, I mean, obviously, what we need to do is, let's say, oh, we have this 2, right? That can either be an A, B, or a C. And then for each of these, we know we still have our 3 remaining, next. So then from each of these, we go to the ones that the 3 can go to. So what? D, E, F, D, E, F, D, E, F. And then our letter combinations are these tuples here. I can use a boom. Just all of these. You get the point. So, and let me see, so that would be true because we got AD, AE, AF all there, BD, BE, BF all there, CD, CE, CF. Okay. So the only thing I don't understand how to do immediately is keep track of this index. Maybe we just need an index. We can start this off with some sort of variable, and we set it equal to 0 up here. And then at each recursive call, we update it to 1. So then we know we're looking at the 3 here instead of the 2. And I actually do think that will work. And of course, obviously, we'll need a map that'll map each number to the things it can. I'll probably represent this as a list here. Yeah. You get the idea. Each number will go to the things it can go to. Otherwise, there'd be no way to kind of know this. So, I like that idea. Let's see if we can write this in code. So first, we're gonna want I'll call this num map, and it'll be a dict. And I think it's just better to statically define this. So 2 will go to A, B, C. I can just kind of uh, 8, 9, cool. A, B, C, D, E, F, G, H, I, J, K, L, it's probably gonna be the hardest part of this problem. This one's got 4 of them. P, Q, R, S. PUV. Didn't even bunch together LMNOP, really? Come on, guys. W, X, Y, Z. Cool, so then I think we're gonna need some sort of like recursive helper. We can call this probably just index. I'll just use I. And return what? Result. Because we're also gonna want a result array of everything in there. Alright, cool. So then we can have our base case. I'll just do this up here so I don't have to recompute it every time. So we can go if I is greater than or equal to the length of the digits. That means I can't index into it. So then we'll have our candidate. So we can do result.append candidate and return. And otherwise, then we try I plus 1 with candidate plus digits I. I think that would work, because then we'd have 0, and our first candidate is nothing, so that won't do anything. And then, we'll go in and 0 will be a digit. No, this is definitely not it. Zero is the index in a digit, so we're looking at the 2. And I want to try adding everything. So number chars in nummap. We want to call this with I plus 1. No, wait, we don't want to loop through the map. We want to go for C in nummap digits I. Because digits I is the string character at the index we're looking at, so nummap will enter us into the list of characters, and this will get the actual character. Then we can do the candidate plus that character. And if it ever gets past this, then we return. I actually like this. Let's submit this and see what output we get. Oh. Forgot our commas. Cool. How about now? Boom. No way. I guess it does all make sense, but did I really just bust this out first try? Dude, let's go. That's actually hype. I would not have been able to do this even just like a month ago. Let alone, I remember I took a course in my DSA course. We had this question. I had no idea. I was like, I'll never be able to figure this out. Wow. All right. Well, then that's the question. Yeah, we just have our mapping. This is our base case, and this is our recursive case. I think I made good use of data structures with my num map and indexing the digits thing, and I like being able to have the candidate as an argument to the helper function, because then it'll take care of the do something, recurse, undo the thing case for you. And yeah, until next time. Thanks for watching. Like and subscribe.